We now know how to create script files, what kinds of things to put in script files, how to make a script executable, and how to tell Bash how to find the script to run it. So that's all great. Our scripts have been really, really simple though, and that's fine. We're just trying to demonstrate how to make scripts. Now that we know how though, it's time to start doing something more interesting with our scripts, which means we need to go past our simple little commands like cat and echo, okay? And in particular, most of the power in a script will come from the fact that you can take a command and make its output be input to another command, so that one command can process the output of another command. In other words, you can make the computer do a lot of work for you. You can make it run all kinds of things. So a command that summarizes data might need a whole bunch of data items from other commands, one or more. The other thing that might happen is you might have a command that makes output that has all kinds of stuff in it you don't want. We'll see a couple of examples of this. But what we're talking about here is we're talking about the mechanism to take the output of one command and make it the input of another, how to combine commands. And we do that with pipelines. So a pipeline in Bash, and actually in any shell that does pipelines, lots of them do, is a way of taking two commands and connecting them together before they start running, and have the output of one automatically be the input to the next one, without either command really knowing that you're doing it. They don't even care that you're doing it. They run normally and process the data. So it allows us to create commands that do things that either the first command can't do alone, or the second command can't do alone, or that neither one of them really was intended to do, but because we combined them in a creative way, we can make them do things neither one was ever knowing how to do. There's three examples on this slide, and I'd like to go through each of those with you to see what they do and why we might use a pipeline. So the very first one is the ls command piped to wc command with the option -l. Well, let's first talk about those two commands and make sure everybody knows what they do. I suspect everybody knows what the ls does. If we say ls, it lists our files. Okay. The wc command should be familiar to everybody. If that has slipped your mind or you don't remember, that's the word counting command. And what wc does is it counts up how many words, how many lines, and how many characters there are in some text. Now you can give wc a file name, so I might say wc my hello world file. And it will look in the file and it will tell me the file has 3 lines. The file has supposed to be 5 words, 36 characters, but it actually has more than that. It's because of the commenting. Well, no, actually, we won't go there. If I look in the file, helloworld.sh, there it is. We can see here 1 line, 2 lines, 3 lines. There's our 3. 5 words. As humans, we'll say that's a word and that's a word, the bin. But the word count program doesn't work that way. It just looks for spaces. And it says there's no spaces in this. That's 1 word. It's not because it's a comment. It's 1 word. This is 1 word. This text, including the quote, is 1 word. In other words, it doesn't speak English. It just looks for sequences of non-space characters. It says, well, that's a word, that's a word, that's a word. So it thinks there's 5 words in this file, although we might dispute it. Okay? And 36 characters. If you count up the actual characters in the file, you'll find there's 36. So that's what WC does. What neither one of these ones knows how to do is tell me how many files I have in this folder. With LS, I can see my file names. With WC, I can take text and count up lines and words and things like that. So what would happen if I were to take the output of LS, which is text, and feed that as input to WC? Now it's going to count the lines, words, and characters in the text that is coming from the ls command. And it's going to tell me, oh, the output of the ls actually has 2 lines with 2 words and 37 characters. You might say to yourself, well, how can it be 2 lines? I can see that it's 2 words, but how can it be 2 lines? There was only 1 line that came out of the ls command. Well, one of the things to know about ls is if you send ls output to a pipe, it automatically puts 1 file name per line. There's a reason for that. When I do ls on my screen, it lists my files, and it fits as many file names on a line as it can. If the number of files here is small, I get output like I've seen here, just a small little list of file names all on 1 line. If I do this for a bigger folder, like the root directory, I'm going to get multiple lines, and it has fit as many as it can per line and made columns out of it. If the list of files changes, the number of columns it displays might change. Also, if I make my window wider so that the lines can be longer, it will again change how many files it can fit on a line. So in other words, ls is an interesting program. It looks at its output to see how to display its output. It's kind of smart. Well, what happens when we take our ls and we send it to a pipe? How wide is that window? There is no window, right? So it has no width. And that's why when you send ls through a pipe, it just puts 1 file name per line. So now what we recognize is, well, if I take the list of files and I send it through a pipe, so I have 1 line per file, no matter how many words are in the file name, I could use word count to count the lines, and I'll know how many files there were. So we could use ls, pipe to WC, with an option that says, I don't want all 3 counts. I don't care about words and characters. I just want to know the lines. How many lines were there? Well, now it'll tell me there were 2 files because there were 2 lines. If I did ls on the root directory and piped it to wc-l, it'll still print out 1 file name per line into the pipe, and WC will count how many lines came out of the pipe, which is the same thing as how many files. So it'll tell me how many files were in the root directory. And it will tell me there were 25 of them. Hopefully everybody's kind of getting the concept here that even though ls doesn't count files and WC doesn't count files, by creatively combining them, we can count files. This is the real power of the shell. You can take simple commands that do simple things and combine them in ways that allow you to do very fancy things, very complex things, or things neither command can do by itself. Let's try the second example. We won't spend as much time explaining it. The first command is the ps command. And the example there, without going into too much detail, is a command that shows me a list of the users running processes on this computer. 1 line per process. That's what the options that I gave that ps command do. If I scroll back through, I can see it's a very long list. There's a lot of processes. So it's only showing me usernames. It's showing me every process. That's what the -E option is. And I didn't put headers, no titles. It didn't put the word user at the top. So it's just showing me usernames. Why? Well, I don't care what processes they're running. What I care is who is running processes, and that's a big list. However, the list isn't organized in any particular way. And what I don't know is, since it's such a long list, it's really hard for me to figure out how many processes is each person running. And as a matter of fact, because I have to do all kinds of scrolling, I can't even very reliably figure out the complete list of who it is, because I might miss somebody. So let's take that list of names and pipe it to a command that will help us with that. First, let's sort them. So all the roots are together, all the Dennises are together, and so on. And that's going to help us a little bit because it kind of separates out the names. It makes it a little easier to see when you're switching names in the output. We still have the problem that there's too much output. Lots and lots of things by user root, lots and lots of things by user Dennis, and then a few other users sprinkled in there. So what we'd like to do now is get rid of all those duplicates. If we want to know that Dennis is running things, we don't need it to print out Dennis 50 times for 50 processes. Just print it out once and we know Dennis is running something on the computer. Well, there's another command we can use. You can take a sorted list of text and you can send it to the unique program. And the unique program will get rid of duplicates in sorted text. So if I allow that to run, now I get just the unique usernames. So that is the name of every user account that has processes running on this computer right now. If I wanted to know who the bigger users were, I could even put an option on unique to say count how many lines you got rid of. And it'll tell me Dennis has 84 processes, he has 2 processes, root has 188 of them running, and so on. So again, PS won't tell us how many processes a user is running. It'll just make a list of them. We have to count them up. Sort is great for sorting data, but it doesn't know anything about processes. And unique is great for getting rid of duplicates and counting them, but it doesn't have any idea what users are or processes are. So it's up to us as the person doing the commands to be creative and to think about, well, if I've got this data, I could do this with it. And then I could use that for something else. And I can make my pipelines as big as I want to make them. So that's 2 creative ideas we could do. Let's look at the third one. We've all used the IP command to look at our IP addresses. It makes a lot of output. Here's the first interface on my computer. Here's the second interface on my computer, and all kinds of information about those interfaces. That's nice. If I wanted to know my IP address, I could run this command, and I could start manually looking through it and apply my own special knowledge of how this command works to say, well, there's an IP address here. Oh, but that's localhost. That's not the one I wanted. I wanted this one. That's what I wanted. Oh, there's an IPv6 address. Oh, yeah, but I didn't want that. I just wanted the IPv4 address. So I am using my own thought process to identify the data I want. How did I find what I wanted? Well, I knew the interface I was interested in. I don't want loopback. I knew I wanted the INET address, not INET6, which is IPv6. And I knew I wanted the second thing on the line because that's my IP address. Well, we can turn those things into commands. We can say IP address. We know we only want one interface, so we can say show just that interface. And now we'll get just that interface. It's still too much data, so we can say, well, yes, but when I looked at my output, I, in my own head, only kept the information that was on the INET line. So I'm going to say grep for the word inet. It has to be the whole word. That's what the -w means. Because I don't want to find the one that says inet 6. So now the only text I have, whoops, I typed grep, I thought. Apparently not. So now I have just that line. But there's still too much data there, right? So I need to reduce that data further. I need to filter out the things I don't want even more. Now, in this case, I only want the second thing on the line. So now I need a command that will just print me the second thing on the line. Now there's a couple of commands I could use. I could use set, I could use awk, I could use cut. I could use all kinds of things. I'm just going to pick awk because it's what's on the slide. And it has a syntax that allows me to do something like this, to say only print out the second thing on the line. So it'll do that. And there it is. What's that useful for? Well, if I'm running the commands, I can manually dig through that big goofy output and find the IP address. Or I could run this command and get just the address, no searching. You might say, well, that's a lot of typing. Why would I do that? To which I will say, what do you mean it's a lot of typing? You only have to do it once and put it in a script file. And then just run the script. And you will always have the address. I could make a script. I will cat into a file called showmyip.sh, and I'll get my input from here until I see ELF. And why am I doing that? Well, it's because I'm lazy. I'm going to just copy this and paste it. And then I can say EOF, and it will make this file with that line in it. I can prove it's there by using cat. I don't have my hash bang in there. Oh no, I got too lazy and forgot. That's okay. I can use my favorite editor, whatever that happens to be, to modify the file and do that. Or I could have opened it in Atom, because if I look over here, Atom knows the file is there. And I could click on it, and there was the file. And you'll notice Atom has a complaint in here. It says there's something wrong with your line. When I look at the bottom, it says, giving you tips depends on what shell you're using, and I don't know, you're missing your shell bang line. No problem, I already figured it out, now it's going to put it in. The other thing I noticed is my copy paste didn't work right. I mentioned before, copy paste can be problematic. It was missing the $2. So I'll save this. And want to know something interesting about Atom? Atom knows the file changed. Isn't that cool? So now anytime I want to know my IP address, I can make my script executable. I only have to do that once. And I can run my script and it will tell me my address. So I just made myself a useful little tool and I never have to dig through my IP output again. Hopefully everybody kind of sees. We can create command pipelines to do useful work. And even if the pipeline looks like a lot of typing, the fact is you only have to figure it out once, like we just did, save it in a script, and you can use it as many times as you like without having to figure it out again. We could make this fancier. We could put more commands in, but that's an exercise for another time. Does anybody have any questions about what a pipeline is and how we can get pipelines to do things for us that individual commands can't? And once we have something useful, we can save it for future use. All right. If there's no questions, then We're ready to go back to our lab, and this is the point at which I'm going to set you loose to finish up the lab on your own. There's an example. The next thing in the script is creating, actually downloading a script called find setID files. So you'll start by downloading an existing script that I'm providing you. And inside the script are comments, and in those comments are instructions for how to improve the script, to make it better. So just like I just made that show my IP and it wasn't quite right, I went in and edited it. I changed it. That's what you're going to be doing. So you're going to download a script to start with, and then you're going to make changes to it. And when it does everything that it's supposed to do, you're going to send it to your GitHub. You're going to save it. And then you can submit lab 1 once you've reached that point. So our lab instructions. Once we've done everything up to this point, we get to the bottom and the section called a useful script. So you're going to download this find setID files. You should run it once and see what it does. And then you're going to modify it. So I gave you a command that lets you download it right off the command line if you want. You don't have to bother with your browser and all the rest of that nonsense. We make it executable, and we can just run it and see how it works. Then you're going to go in and change it. My example says use VI. You don't have to. You can open it in Atom, which is actually the nicest way. You can use Nano if you want to. You can use anything that you can use that you like to use to edit a text file. I'm going to recommend that you use Atom because it will help you with typos. Okay. Make sure it all works and save it to GitHub. And as a quick reminder of GitHub, well, I did just make a script called show my IP. I have some unstaged files. So I'm going to stage them. I'm going to put in a message that I created files for lab 1. I'm going to commit. And then I'm going to push. So stage, commit, push. When that's done, if I were to refresh my GitHub page, I should see I have more files. And when you have all of the files for this lab ready, that's when you submit lab 1 on Blackboard. And then I can review that with you and make sure it's done right and give you your marks. And that should be done for next week.